Hi, everyone. So we're going to get started. While you finish setting up, I guess I will give a little bit of an introduction to today's seminar. So today is our last seminar of the winter quarter, and it's also our special Blackwell Seminar celebrating the life and work of David Blackwell. So I think many of you have actually participated in choosing the speaker for this year by participating in DICE last year. So here we have Alexandra, who we've all selected and who is going to give us a wonderful talk today on algorithms in unjust systems. So a little bit about Alexandra before we start. So Alexandra Chouldechova is a principal researcher in the Fairness, Accountability, Transparency, and Ethics group at Microsoft Research NYC. She is currently on leave from CMU, where she is the Estella Loomis McCandless Associate Professor of Statistics and Public Policy at the Heinz College of Information Systems and Public Policy. Her research investigates questions of algorithmic fairness and accountability in pre-trained models and data-driven decision-making systems with a domain focus on criminal justice and human services. Her work has been supported through funding from organizations including the Hillman Foundation, the MacArthur Foundation, and the NSF Program on Fairness in Artificial Intelligence in collaboration with Amazon. She's a member of the Executive Committee for the ACM Conference on Fairness, Accountability, and Transparency, FACT, and previously served as a program committee or co-chair for the conference. Dr. Chouldechova was a 2020 research fellow with the Partnership on AI, served on the Pittsburgh Task Force on Public Algorithms and the Arnold Ventures Pre-Trial Research Advisory Board, and was on Amazon Scholar with AWS AI. She received her PhD in statistics from Stanford University and an HBSc in mathematical statistics from the University of Toronto. So we're very much looking forward to having you give this talk, and let's all welcome our speaker. Sorry, I forgot to say one more thing about questions. So Alex has asked that if you have clarifying questions, please ask them during the talk, but any longer questions, please leave them for the end of the talk, and same for the people on Zoom. So if you ask your questions in the chat, if they're clarifying questions, I'm going to interrupt. Otherwise, we'll just leave them for the end. Thank you.
All right. Thanks so much for the introduction. Can folks in the room hear me? The mic is working okay? Excellent. All right. So hey, everyone. Firstly, I would very much like to thank especially the graduate students of the Department of Statistics for the honor of speaking here today at this year's Blackwell Seminar. And thank you also for everyone who's tuning in, be it in this wonderful, lovely room with a wonderful view in person. I really love the greenery coming here from the concrete jungle of New York City. And thank you all for tuning in remotely. That's why you're here today. So as Emma mentioned, today I'm going to be talking about algorithms and algorithmic fairness. And when I say algorithm, think like prediction model. Okay, I'm just going to be using the colloquial term as it's been adopted in the public media. And specifically, I'm going to be interested in issues of algorithmic fairness when those algorithms are being deployed in systems that are themselves perceived to be unjust. And rather than try to cover the whole swath of systems of this kind, or even just a subset of ones that I've worked on, I'm going to focus on one such model system, which is the child welfare system. And my slides will advance one day, or they won't. And it no longer works. That's okay. Actually, none of this is advancing. Give me just 1 second. Okay, now that's working. Is my, okay, still on Zoom? Okay. Technology. Okay. So, well, I'm going to focus on the child welfare system rather than telling you about a single project or just my own work in this area. What I'm going to hope to achieve today is to provide you with an overview of what algorithms in the child welfare system are, describe some of the work that we've done, in particular work that's been inspired by concerns raised by journalists and civil liberties organizations, and then to give you an overview of some of what research has found about the impact of algorithms deployed in the child welfare system. So let me tell you a little bit about the child welfare system, at least in the US. So at a high level, the ultra simplified version of the system looks like this. The more complex version runs for pages, and you can find it in a RAND report if you're interested. So first, what happens is someone observes something that leads to suspicion of abuse or neglect. And this person is often a mandated reporter, such as a teacher or a doctor who is required by law in most states to report any suspicions to the state authorities. So those individuals, once they have a suspicion of maltreatment, they make a report, also known as a referral, to state or local child protective service agencies. And there, the call is typically routed to a local agency, typically run by the county. There, a person called a call screener decides whether that report or referral should be screened in for investigation or screened out. So a record is made, but the family is never notified, et cetera. For referrals that are screened in, a caseworker, so not the call screener, but someone else, then conducts an investigation where they determine whether the allegation is substantiated, whether the children or family involved need services, and whether the children involved are at sufficiently high risk to require the opening of a case to continue working with the family and monitoring them. If a case is opened, the children may either stay with the family, or if the risk of that is perceived to be too great, a court petition may be filed to remove the children from the home, place them outside of the home, resulting in what's called an out-of-home placement. And for children who are placed out of the home, there are then decisions to be made about reunification. So whether to reunify with them with their parents, and if so, when, or whether to terminate parental rights. And to give you a sense of scale of the system, I think the child welfare system shares a lot in common with the criminal justice system, depending on where you grew up and what community you're part of. Either everyone you know has been involved in the system, or no one you know has been involved in the system. So in terms of 2019 statistics, which is the most recent data we have from before the pandemic, it's estimated that agencies around the country received 4.3 million referrals on 7.8 million unique children. And as a result of those reports, 3.5 million children received an investigation or an alternate response. And estimates suggest that at least 1 in 3 children in the US will experience a Child Protective Services investigation by the age of 18, and 1 in 8 will, so children overall in the US, by their 18th birthday will be confirmed as victims of maltreatment. So Black and Indigenous children are especially overrepresented in the US child welfare system. While Black children represent approximately 14% of the US child population, they actually make up 23% of children in foster care, and that itself is a tremendous decline from numbers in the 30% range in the past decades. Black children are also more likely to be reported for suspected maltreatment in the first place. Once reported, their cases are more likely to be screened in for investigation. Once investigated, the allegations are more likely to be substantiated. They're much more likely to be removed from their family and placed in foster care. And following removal, Black children are also less likely to be reunified with their families and end up spending longer in foster care as a result. And the last thing I'll tell you about the system by way of context setting is, while I'm going to be using more neutral terms such as the child welfare, child protection system throughout this talk, many reasonably argue that these are in fact misnomers once you delve more deeply into the underbelly of this system. Indeed, many have argued with good reason that more appropriate names for the system are the family regulation, surveillance, or policing system, which I think conjure to mind very different institutions from something about welfare and protection. Similarly, how policing is about protection, but we understand that there are deep, entrenched systemic issues with that system as well. And the concerns are that this is a system that, despite the good intentions of many individuals operating within it, operates through invasive investigation, monitoring the separation of children from their families. And while some of those actions are no doubt warranted as responses to severe incidents of abuse, most of the allegations that are received by these agencies, usually 70, 80, or even 90% of the allegations that these agencies deal with, involve neglect, not physical or sexual abuse. And neglect often arises from conditions of poverty. So while the system is technically able to connect families with supportive services, just as police are capable of enforcing laws and connecting people with the resources that they need, the child protection system is typically viewed as really ill-suited to providing the sorts of material supports that can alleviate the conditions of poverty and the symptoms of poverty in a direct and minimally burdensome and also non-coercive way. So in some sense, it's not the best tool for the job that needs to be done. And so these are themes that I'll return to over the course of the talk, but in the meantime, let me tell you a bit about algorithms that operate within the system. So algorithms entered the scene at least as early as the 1980s as part of broader efforts to improve decision-making and to help workers cope with the sheer volume of cases at every stage of the child welfare system, as I just described. So originally, the sort of tools that were used were mostly actuarial or psychometric tools, and I'll describe what I mean by that. But in the past decade or so, predictive risk models have entered the scene. And these are models that are developed using large administrative data sets and using machine learning methodology, in other words, non-parametric statistics. And they've been attracting considerable attention that hasn't really been paid to the more actuarial or psychometric tools. And the hope, irrespective of kind of the structure and nature and origin of the tool, is that they can help provide additional information or structure the reasoning process when making decisions under uncertainty in a way that reduces noise, potentially reduces bias in decision-making, and ultimately improves outcomes for families. According to a recent report by the ACLU, algorithmic tools are actively used or have at least been explored by agencies in over 20 US states, the ones in color. Orange here means explored or dropped. And various forms of algorithmic tools are used at every stage. So I'll focus a lot on the call screening stage, the so-called front door to the system, when you have to decide whether a report should be investigated. But they're used from deciding which referrals to investigate in the first place to foster care placement to reunification decisions. Most of the systems that are in use today are some form of actuarial or psychometric tool. These rely on subjective assessments or self-report during interviews with caseworkers. So what I'm showing here is a snippet of the child and adolescent needs and strengths assessment, also known as CANS, and there are different versions of this. But basically the way it works is through an interview process, a caseworker assesses the individual on a bunch of these points, assigns a point value. Those points are then tallied into multiple scores called scales for assessing different forms of risk or need. And some variants not only just provide a score on a scale, but also produce a decision recommendation, what to do for an individual with that score. There's been some excellent work, both quantitative and qualitative wise, on how such tools are used in practice and how the users of those tools feel about them. And I especially want to highlight here a pair of studies from the past couple of years by Devansh Saxena and Cheyenne Guhan, their co-authors. So in one of the framework study, for instance, the authors do a deep ethnographic study of one child welfare agency and their decision-making, and they document how caseworkers interact with various actuarial and psychometric tools used in investigations and open cases. And caseworkers in the study describe how algorithms can fail to use relevant data, can lead to gaming and cumbersome bureaucratic processes, and also introduce conflicting values. They have some really fascinating stories about the CANS assessment, where if you're interested, I can tell you later. In the remainder of the talk, however, I want to focus on a different set of algorithms, which are these predictive risk models. People don't like calling them risk assessments, even though they are structurally and statistically the same, in part due to the connection with criminal justice risk assessments and the baggage that that carries. So unlike actuarial or psychometric tools, which involve subjective assessments and interviews, predictive risk models are based exclusively on administrative data. And so all that a call worker needs to do in order to run one of these is not actually talk to people and assess them in terms of their risk and needs, but rather to find out enough information to be able to uniquely identify them in the administrative data system. Once all the children and adults associated to a referral are identified, the model is run by pulling all administrative data associated to those individuals from the database and producing a score. And the data that's pulled in can be multi-system. It really depends on the data capacity of the agency. Some agencies are very data rich and have linked systems. Some agencies are more limited in the data that they have. And so in the more rich data settings, this data can include things like demographic information, prior child welfare system involvement, criminal history information, physical and behavioral health information, and more. And what predictive risk models do is they take this administrative data, which once you expand it out to some sort of feature set, numbers in the thousands, and they estimate the likelihood that the child will go on to experience a bad outcome. Right? So since most of the salient outcomes, such as harm and abuse, are not directly observable in each instance, what the models target are more observable proxy outcomes. And I'll return to this a little bit later on. But these are things like the likelihood that a child will be re-referred, which we get to observe, or that a child will be placed in foster care if they're going to be screened in for investigation. And because these systems are based exclusively on administrative data, so someone just needs to find the identifiers and then the system runs itself, they're less subject to gaming. And people like this because then workers cannot manipulate the inputs, the score, to get the score that they want, but they can still make decisions that, of course, go against the recommendation or the assessed risk. So here's an example of a predictive risk model that we'll use, that we'll see recur again in some of the studies on impact. And this is the AFST, or Allegheny Family Screening Tool. So it outputs a risk score from 1 to 20. And originally, the AFST predicted both re-referral and placement risk, so the likelihood that a child will be re-referred in the subsequent near future, and the risks and the likelihood that they will be removed from their home. The purpose of this tool was not to find children to re-refer. It was also not to find children to remove from their families. The purpose was to identify children who are at high risk according to measures that the agency believed correlate with harm, and to screen in those cases for investigation. In the latest versions of the AFST, which has been in deployment since August 2016, the latest versions from like 2019 onward just focus on placement risk. The re-referral scale has been dropped. So even though the AFST, the latest version of it, is targeting placement risk, right? And so it's not a direct measure of harm, it's not a direct measure of abuse. In one of the studies that we published in JAMA Pediatrics in 2020, what we looked at is whether that tool, which isn't actually constructed to predict medical outcomes, is nevertheless associated with medical outcomes that can be interpreted as indicators of a physical harm. So what's being shown here is the rate of a medical encounter per 1,000 children. The black and orange line are just different ways of thinking about a score up to a certain point, and we're looking at the outcome in some time period after, assess at time points. Like we go up to 2018, we look at either a random score that the child received if there have been multiple referrals, or the maximum score. And then we see if that correlates with subsequent rates of medical encounters. So we're trying to predict the future here. And what we see is that there is a strong positive association with any injury hospitalization, with hospitalization on maltreatment-related ICD-10 codes, with suicide hospitalization. This is now getting into rare events in the upper tail. And then we wanted to come up with some sort of placebo test to say, well, this score isn't associated with every single medical outcome out there. So if you look at cancer, for instance, which should really have no or little association with any proxy for harm, there's virtually nothing. But again, our power to detect association is going to be so low that we wouldn't necessarily expect to find something. Okay. So from the very beginning, the use of predictive risk models, these risk assessments in child welfare, has received considerable criticism, both in the media and from organizations such as the ACLU. And most recently, it's never a dull moment, the Department of Justice is actually scrutinizing the AFST for potential discrimination against parents with disabilities. So that's going to be an evolving case that I'm very interested in following. And largely, the concerns have been over issues of potential bias and further marginalization of communities of color and those experiencing poverty. And what I'm going to tell you next is a bit more about some of these concerns, and I'll overview the sort of statistical questions that they give rise to, and at least the partial solutions or answers and investigations that we've done. So the first one that I'll start with is some of the issues raised by this Wired article. This Wired article from 2018 is based on Virginia Eubanks's book, Automating Inequality. And in this book and in the article, Virginia Eubanks critically examines the AFST, this tool that I've been telling you about, which again is used in call screening to help decide which reports of child maltreatment should be screened in for further investigation. And among the points that Virginia Eubanks makes in this article, she argues that by relying on data that's only collected on families using public resources, the AFST unfairly targets low-income families for child welfare scrutiny. So let me unpack that for you a little bit. The issue that she's getting at is the administrative data systems that are used for training and then running the model. They have a lot more data, a lot more complete data on individuals who rely on public services. So for instance, the systems have fairly complete information on behavioral and physical health utilization for those who are covered by Medicaid, because those claims go through the county. They're oftentimes funded in part through the county through reimbursement from the federal government. And as a result, we have fairly complete information there. But we have very little to no information on the privately insured because their claims are not submitted through the county. And this critique got us interested in formally investigating this question. So the question here is, are groups with more complete data unfairly targeted by prediction models? Now, this isn't a precise statistical question yet, but I'll show you how we tried to make sense of it. So to get a handle on this question, working with my student, Ilyana Akmanar, who's graduating this year, and collaborator Zach Lipton, we put together a simple model of sort of underreport. And in fact, it's a model of unreport, as I'll clarify soon. So here, what we assume is that we have some sort of group variable G. This may be unobserved for various reasons. So it could be something like whether someone is privately insured, right? And that's going to be governing unreport. And we have true features Z that are going to be mismeasured, right? So Z could be like the actual, it could be things that are not mismeasured. So things like demographic information, which we assume are actually going to be correctly observed, and other things that are subject to underreport. So things like behavioral health utilization, physical health service utilization. And then there's some outcome Y that we're going to be trying to predict, right? Y is going to be observed and Y depends on Z. What we get to see in terms of features are these X's, right? And the X's differ from Z in that for some of the features, the ones that are subject to misreport, to mismeasurement, instead of seeing Z, what we actually see is Z times this psi variable, which is a missingness or unreport indicator. So the way that you should be thinking about this data is when we see an X equal to 0, this could be coming from a person who actually, for instance, didn't have any substance use services in the past year, or it could be someone who did have substance abuse services, but those were privately funded, right? And so the 0 really means that in our administrative data records, we have no record of this, but they could have actually use those services. So then what we're going to do is we're going to do the only thing we can. We don't have access to the Z features. We're going to form a model based on X. And when I say the only thing we can do, the thing that's done in practice. Okay, we're going to form a model based on X, the set of features that are a misreported version of Z. And we're going to think about what are the implications of doing this. Lovely. There we go. So we frame this question of groups being unfairly targeted by prediction models in comparison to the predictions that we would get if we had access to the true features Z. Okay, so I'm going to be interested in asking the question, when you observe X instead of Z, so the features that are subject to misreport, like you don't get any information, or you get zeros for everyone who's privately insured, does that increase the rate at which the group with more complete information is assessed as high risk? Okay, so let me unpack that for you. Shown here is a mock-up of what the predictions of Y regressed directly on Z could look like. The red density here is the predicted risk distribution. So like the Y hats for group A, which let's say this is the group with no unreported. This is the complete data group. And the blue density is the like predicted distribution from the regression of Y on the true feature Z for the population that's subject to frequent misreport. But in this case, everything's fully observed. So then we're going to pick an overall target selection rate, such as 10%. So I'm going to say I'm going to flag the top 10% of overall cases as high risk. And I'm interested in, okay, under this Y on Z regression, what fraction of cases from group A, the group with more complete data, are identified as high risk. And so here it's 9% of cases. Okay? Because there's a little bit of a difference in the true feature distribution between the two groups. Okay. And we can compare this to what we get if we do the regression of Y on X and look at the risk scores there. So here, what's being shown, like in this mockup, is that if we have access only to the features X and we regress Y on X, the risk distribution for group B, the one with more unreport, winds up reducing in variance. It concentrates more around its mean. And so then as a result, when we look at the top 10% of highest risk cases overall, we wind up with now 16% of group A, the more complete data group, being classified as high risk. Right? And that's a big increase from 9%. So in this case, this would be, if this is the situation that actually happened, then this would say that, well, by using just the observed features compared to what you would get if hypothetically you had access to the true features, group A is selected at a 16% rate as opposed to 9% rate, and that's a huge overselection. So that would support this hypothesis that groups with more complete data are unfairly targeted by prediction models. Okay. So we're not the first to study the impacts of feature mismeasurement on algorithmic fairness. Indeed, there's been a series of papers considering additive feature noise, and those have found, for instance, that even if you have an equal level of noise, you can still have loss discrepancy between groups when the feature distribution varies between groups, when the Z distribution varies between groups. And there's other work on missingness with observed missingness indicators. So when you know that some data is missing, like it appears as NAs in your data table. And that work has explored the disparate impacts of different imputation methods, typically finding no consistent results in terms of whether one imputation strategy outperforms another. Right. And the difference between the standard missing data setting and our unreport setting is that we assume that we don't observe the missingness indicator. So I don't know whether in this case, we're assuming that things default to 0. When I see a 0 in a feature that's subject to misreport, I don't know if that's a real 0 or an unreported 0. So I don't know if the person never used the service, or I just don't see that they use the service because they didn't rely on public funding. Is the setup here clear?
So,
yeah.
Would it be better to call it measurement error?
Pardon me?
Would it be better to call it measurement error?
Yeah, so we are referring to it as unreport here or underreport because it feels more aligned with that line of studies, whereas measurement error, at least in the study of algorithmic fairness, has come to mean like this additive feature noise. So we're trying to use terminology that doesn't get confused with the additive feature noise setting, because this is not additive feature noise. And so like feature mismeasurement has been appropriated for that other setting. Is that at all helpful? Yeah, so you're not wrong, but we're just trying to distinguish the methodology for clarity within the subfield. Okay, so now let's get back to our question. Are groups of more complete data unfairly targeted by prediction models? Right. So the first finding is that in theory, the answer is not always. Okay? So it is theoretically possible to have selection rates decrease for the group with more complete data when you have unreport. So in other words, it's theoretically possible that when you have unreport, right? So we're going to have frequent unreport for the blue group, like the blue group is the privately insured group, that when their data is unreported, and then you train a model on the unreported data, and then you predict on the X data, the unreported mismeasured data, you can wind up with a more diffuse rather than concentrated distribution for the group with less information, less complete information. And that can have the effect of decreasing selection rates for the other more complete data group. Okay. So we can go from like 9% selection to 6% selection. Okay. And here's an example in which it arises. And I want to present this just so that you see like how kind of perverse the setting has to be. So suppose that we're in a linear model in terms of the true feature Z. The feature vector Z is multivariate Gaussian with the same mean mu and variance sigma across both groups. And let's just say the first feature is subject to unreport or mismeasurement, and the other features are observed correctly. So in this corollary in our paper, we show that the group complete data will actually have lower selection rates at sufficiently high thresholds, so lower selection rates than in the complete data setting, right? If the following relationship holds between the betas and the covariances, the dependencies between the features. So C is some typically largish positive threshold. So when does this sort of thing arise? Well, this can arise because we only have two features. The first one is subject to misreport, the other one is observed correctly. If we're in a case where both of them are risk factors, so beta 1 is positive and beta 2 is positive, and yet the covariance between them is highly negative, this sort of setting can arise. I wish I had a kind of plain language compelling example of when this happens, but it really does feel like a mathematical edge case. It's hard to come up with a compelling example of something like this. But if you have one, I will give you candy or Amazon credit, whichever one you prefer. Okay, so finding number 2 is kind of motivated by finding number 1, since I told you that that one is sort of like perverse and mathematically possible, but doesn't really arise in practice, is that in practice, the answer is typically yes. Selection rates do typically increase for the group with more complete data. So typically we do land, and we've investigated many, many different data sets to try to pull in real correlation structures and relationships between the outcome and features, and do all kinds of like synthesis to mimic misreport. Typically you wind up being exactly the situation that Virginia Eubanks describes, where the group with more complete data is selected at higher rates. Okay. So now let me make this a little bit more concrete by walking you through a realish child welfare data example. And this one is inspired by Allegheny County's Hello Baby program. So rather than looking at a use case where a child has been referred to the child abuse hotline and we need to make a decision, this is an at-birth prediction model that's used to prioritize voluntary services for families with newborns. So when I had a baby in the county in December 2020, just shortly after the Hello Baby program was deployed, I got a flyer and was informed about this at the hospital. And I could reach out and say, I want voluntary services, right? Or I want to understand more about this program. How can I benefit? Okay. My family has no child welfare history that I'm aware of. I could have been reported. I wouldn't know. I've never been investigated, but I was eligible for consideration through this program. So there's an at-birth prediction model that's used to prioritize the most intensive and expensive level of service to those who are at highest risk of having their current newborn removed from the home in the first 3 years of their life. So what do we do to try to mimic this? We obtain birth record and administrative data from an unnamed US county. They are choosing to be unnamed just for sensitivity issues. And we tried to mimic the Hello Baby model just by looking at the methodology report and trying to do something similar. So what we looked at is an outcome, which is 3-year placement. Like, is this newborn child born today, based on the information that you have now, are they going to be removed from the home, from their family in the first 3 years of life? We then have G observed in this data, which is whether the labor and delivery stay is covered by Medicaid or privately insured. We have parent demographics, newborn vitals, things like whether the mother intends to breastfeed, et cetera, and also family, child welfare, and criminal justice history. In addition, we have behavioral and physical health history for the individuals here. So what we're going to do is we're going to mimic under report, because we do have a plausible G variable, like whether the labor delivery stay was privately insured. And we're going to correctly observe everything except for behavioral health history, where for everyone who's privately insured, we go and we synthetically zero out all of that. Okay. Let me show you what happens. So here's what we find. And what I'm showing you here is no longer the two density plots. I'm actually showing you a ratio. And what we're going to be looking at is how the selection rate for the Medicaid group, so the complete data group, compares when we have unreport in the data, right? So where we're modeling with the privately insured behavioral health all zeroed out to when we don't. Okay. So the x-axis is now the overall selection rate, and we want the overall selection rate here to be quite low because, again, this is among all newborns that are born, many of whom have no prior history of child welfare involvement or any like serious needs that would raise concerns. And we're interested in flagging those. Okay, so the overall selection rate is going to go from 0 to 10%. And what I'm showing you here now is like, if you look at the red horizontal line, that's just at 1. That's simply saying that the selection rate on the true data divided by the selection rate of the regression on the true data, so it's same numerator, same denominator, that's 1, okay? So this green line, it shows the ratio, so the selection rate that you get when you look at the Y regressed on X model divided by the selection rate that you get from the Y regressed on Z model. And the selection is for those who are Medicaid funded. So that ratio winds up being approximately 1.1, okay? Which means that the fraction of Medicaid funded families that are identified as above threshold, like at these different selection rates, is approximately 1.1 times higher than it would be if you had access to the true Z data. And the blue line shows something that's typically suggested by critiques of these systems, which is don't use the information that's subject to misreport. Okay, just use everything else. And in this case, we see that that would give a selection rate that's a selection ratio of about 1. Okay, so approximately equal selection rate. So then we look at the misreport is still based on Medicaid funding, but we're going to look at a different group. We're going to look at the effect on the selection of Black families. Yep.
There's a question on Zoom, what is BH?
Behavioral health. Okay, so this is like treatments for substance abuse or mental health issues. Okay. Thank you. So what we see now is that if you rely on just the X data, right? There's a slight overselection for Black families compared to if you had the full Z data, which we don't, but not much. But if you omit all the behavioral health information, your selection rate for Black families is actually much higher. So they're much more likely to be classified as high risk at all these various thresholds. Okay. So let's actually revisit this question of, are groups with more complete data unfairly targeted by prediction models? What I've shown you here is that they're over-targeted. Let's get at this fairness question. Okay. So what we see here is that both in the semi-synthetic, in both of these examples, again, they're semi-synthetic, but they're as close to reality as we can get with the data that we have. Both Black families and those on Medicaid are over-targeted when we misreport behavioral health information for the privately insured. Right? But if we think about it, programs like Hello Baby are designed to offer voluntary supportive services. No one came into my home and said, we're going to do X. No one ran the model without my consent. That was actually part of the process that was arrived at to preserve privacy and autonomy. And so in some senses, this can be viewed as a benefit. So being classified as high risk makes you eligible for potentially intensive and expensive supports. Right? So to the extent that this is a benefit, and it's not a no strings attached, I want to be clear about that, because service providers are mandated reporters. And so this also subjects families with tremendous need, often experiencing poverty, to mandated reporters who are required to report conditions of neglect, which again, oftentimes present from poverty. Okay. So it's not no strings attached, but to the extent that the sort of eligibility for the highest level of supportive services is a benefit, it may actually be argued that this sort of over-targeting is perhaps not unfair. Right? So we know that there is over-targeting, it typically arises in practice, but whether or not it's unfair surely depends on the particular decision being made. Yep.
I'm sorry, in this plot, what does the x-axis represent?
It was shown here, it's the overall selection rate. So over here, we're saying that we're going to flag 10% of cases as high risk, over here 2.5% of cases as high risk, just in descending order of their risk score. Yep. Great. Okay. So we studied other questions that have been inspired by just reading what writers and civil liberties groups have said. So for instance, one of the things that we've investigated was based on related reports outside the child welfare context that talk about the impact of proxy outcomes and target variable bias. So outcomes that aren't actually what we care about, they're just what we happen to observe, when those can be perhaps biased against certain groups. And this is the type of problem that we previously studied in the criminal justice setting with this paper with my former student, Ricardo Fogliato, who's now based in Seattle, works for Amazon, and my collaborator, Max Gazelle. And so what we specifically look at is, suppose that you're interested in understanding how well does a model that you have, or how fairly does a model that you have predict the outcome that you care about when you only have the outcome that you observe. Okay? And we take a fairly straightforward sensitivity analysis approach to try to incorporate the uncertainty having to do with the disconnect between the thing that we care about and the thing we observe, in addition to the statistical uncertainty in our estimation. Right, so that was an AI stats paper. And now in more recent work with our Microsoft research intern, Jamel Watson-Daniels, and colleagues and her mentors, Solon Barocas and Jake Hoffman, we examine an issue that has to do with the situation that oftentimes we have many possible whys, many whys that are observed and many whys that we care about might not be observed. And so does it matter how we choose between them or how we combine them? That's what we look at investigating. And so this paper that's soon to appear in preprint provides a framework based mixed integer programming to characterize the extent to which people's decisions, so individuals' decisions about a family, will change depending on how you treat the multiple outcomes, like how you combine them into a single scale, how you choose between them to say, no, we're only going to prioritize placement rather than placement of referral or a combination thereof. And this work builds on recent work in predictive multiplicity in the single target setting, and is an interesting story about how the choice of target really matters, and it oftentimes matters a lot more than, for instance, doing imposing fairness constraints on a single target outcome. So you have a lot more space to maneuver when you have multiple targets, especially when they're only loosely correlated. Okay. So I just spent a lot of time telling you about what the media, what civil liberties groups think about algorithms. But that's just one side of the story. In particular, in assessing the merits of these systems, we should really think about community perspectives. So let me tell you a little bit about that. We set out to understand, how do people who are most likely to be subject to these sorts of tools feel about decision-making in this context? And what are the primary sources of discomfort? And also, what can researchers do in the development and deployment phases to raise comfort levels among affected communities? And as I'll discuss at the very end, this last point, I think, this question was framed very, very incorrectly. So we ground this study in the structure of organizational justice perceptions, which is a body of research that originated in investigating employees' attitudes towards their employers. So Colquitt, in their 2001 seminal study, identified 4 dimensions of organizational justice perceptions, which are procedural justice, which is the perceived fairness of the processes that produce decisions and outcomes, distributive justice, which is the perceived fairness of those decisions and outcomes, informational justice, which is the sufficiency and completeness information that's provided to explain and justify decisions, and something that'll be really important in our study, interpersonal justice, so the extent to which people are treated with dignity and respect by those who are making and communicating those decisions. So we ran a study with 83 participants across families, frontline providers who are people like caseworkers who engage with families, and specialists who might work in the data centers or something like that, very familiar with the child welfare system, but don't engage with families. And we, rather than ask them technical questions about how do you feel about this logistic regression model, we framed everything in terms of a fictional scenario, Nicole's story, that tried to convey different dimensions of the use of algorithmic tools, the degree to which those tools are automated or permit human discretion, the degree to which the decision is reactive, so responding to a report of child maltreatment, versus proactive, so offering voluntary services when a child is born, and also the data that gets roped in. Is it narrowly focused on criminal justice history, or is it everything about you and your neighbors? And what we found in the study is that for the most part, people did not distinguish between algorithms and the injustices of the system within which they're deployed. And this is not surprising. If I ask you whether a tool for conducting an unjust act is fair, that question almost doesn't make sense. So families, for instance, most strongly voice the concern that their prior interactions with the system have been largely adversarial. It doesn't really matter if there's an algorithm involved. All participant groups raised concerns about bias on behalf of the algorithm, the data, and also the people operating within it. And in fact, one of the frontline providers raised exactly the question that we were talking about before, which is, if someone is privately insured, their records are simply not part of the system, and that could be, and in fact is, an important source of bias and disparity. Also, participants questioned whether statistical models could actually account for all the factors that they care about in determining decisions and supports, and suggest that we need a more human in the loop approach. And interpersonal issues really writ large. They didn't want to be told that you have been assessed by a statistical model. Essentially, that piece of the conversation is a non-starter. Lastly, and this is the part that I'll delve into a little bit more, is that in addition to wanting some paths for recourse, the ability to question these sorts of assessments and question their validity, they also wanted to see whether having an algorithm improved anything. So specifically, did it help improve child safety? Did it decrease disparities? Did it contribute to strengths-based family support? Right. And back in 2018, when we were conducting the study of effective community perspectives, there was no evidence on this. The AFST had just been deployed in August of 2016, but now we actually have data some years later from both observational studies of the AFST in Allegheny County and RCTs from some unspecified counties and counties known to be in Colorado. So let me tell you a little bit about what those say. So the basic idea for the AFST or any of these tools is we're going to be in the call screening setting. We're going to decide, using information in an integrated data system and the information on the allegation, whether to investigate a case or to screen it out. And the AFST tool produces a score from 1 to 20. Cases that are sufficiently high risk follow a high risk protocol, and they require supervisors to be able to override the recommendation to screen them in for investigation. And later on, there was a low risk protocol added. So there's this paper that recently came out by Catherine Rittenhouse and co-authors that investigated the impact of the AFST on racial disparities, which is one of the things that the families and frontline providers and specialists said they would be interested in understanding more. So what this study found is several things. One is that the predictive risk model generally does not have an impact on disparity. So what you see here is the score from 1 to 20 on the x-axis. The blue line is the screen-in rate for, so the rate at which cases are investigated at that score for white families, and the black line is the screen rate for Black families. Pre-deployment is on the left and post-deployment is on the right. So overall, there wasn't actually a big shift. Right. However, there was a bridging of the gap for the highest risk cases. And most of this can be attributed to that high risk protocol that says for cases that are 19 and higher on the placement scale, there is a default to screen in unless a supervisor overrides that. There are also two other findings. So the first finding was that the use of the predictive risk model reduces racial disparities in screen-in rates for the highest risk children by 9.6% or 98% of the pre-existing gap. It also reduces racial disparities in case opening rates by 5.5%, which is 87% of the pre-existing gap. It also reduces racial disparities in 3-month removal rates by 2.9%, which is 76% of the pre-existing gap. And there's another study that's based on a randomized control trial in a different setting. And this is, whereas Allegheny County has a very large African-American population, this place has only 4.6% of the children who are referrals being Black, right, compared to 50% of children in referrals being Black in Allegheny County. And what this study finds is that in a randomized controlled trial, where it was actually decided through careful randomization at the family unit level, because again, families can be screened in, or families can be reported repeatedly. Availability of the tool reduced the disparity in screen-in rates for low risk, so below median risk Black children. There was no observed difference in screen-in rates or disparity for higher risk children. Right? They also found that availability of the predictive risk model in this RCT reduced child injury hospitalizations by 32%. And they also found that screen-in rates or decisions were actually less aligned with the predictive risk model or the scores when staff have access to the model. So this is the only time I've seen this sort of result, but this is basically saying I'm giving you a tool. And when you have access to the tool, your decisions contradict the tool more or less consistent with the tool than when you don't have the tool. And yet you are seeing these reductions in disparity and this reduction in child injury hospitalization, which is surprising. Okay. So this provided some evidence that we do reduce disparities through the deployment of these systems, even if mysteriously that's not always through greater adherence to those risk recommendations. And the question is, should this provide comfort, right? So should people feel more comforted by these results? Okay. And I'll conclude with this. So last year we published a study that went back to a different set of affected communities and asked them to imagine new futures beyond predictive systems and child welfare, and also to reflect on their concerns that they may have about predictive risk models. This is similar to the study I previously described. We have 7 workshops, 35 participants, including family, former foster youth, caseworkers, and attorneys and students. And so in addition to echoing many of the concerns that were raised before, participants here voice that maybe these predictive risk models, especially if you can show that they reduce disparities or doing something or do something positive, maybe they're good increments in the meantime. But that fundamentally, even if they reduce disparities at some level or increment us in a more positive direction, they can't possibly address the core structural and systemic issues of child protective services. And in particular, more than one participant questioned our motivation for doing the study in the first place. So I'm not sure how often you get pushback from your study participants, or if you have study participants, or if the rows of your data come and ask you, why are you looking at me? But there were participants who asked, why were we trying to do this? Perhaps what we're trying to do is to anticipate the objections of potentially skeptical people so that the sponsors or us will be better equipped to resist objections in order to further develop their tools, sell them, become more prominent in their academic fields, and to make money. And another participant asked, like, what's the point of all this? Why are we thinking about these predictive models? We have such deep structural and systemic issues. Are you just doing this to publish a paper, advance your career? Is this something that you actually think could help families who are harmed by child protective services? Okay. And I really value the participants who spoke up in the study, and rather than just responding to the questions that we had, turn the tables on us and had us reflect more deeply about the questions we should be asking. So where does that all leave us? What I'm going to say here, since this is a talk about racial disparities and social justice, is that I have come to believe that algorithms operating as components of unjust systems cannot meaningfully be described as fair. Like, this is just going to be a misnomer and a contradiction in terms given the realities of the systems and the structure. They may, as we have seen through consistent studies, produce improvements over the status quo, perhaps by reducing disparities in decision-making or reducing the rates of downstream outcomes, such as injury-related hospitalizations. But alone, they are simply not the right tool to address the case of systemic issues with which the individuals who are deeply impacted and sometimes wronged by these systems contend. So at best, they could be part of solutions that are otherwise centered on policy change, reform, or for those who feel like all the reforms have failed, abolition. So thanks so much.
Great, wonderful. So I think Alex would take questions now. So if anyone has questions in the room.
This is a really cool talk. I'm curious what you make of what seemed to me to be like kind of conflicting results between the people who studied the Allegheny family system and found that it reduced bias versus like your results, which kind of seem to show that based on missingness, you're introducing bias. Like, how do you kind of reconcile those, and what do you think kind of the next step forward is?
Yeah, so I think this is a great question. And this, I have like an origin story to go along with it, but I'm not going to give you the entire thing. But basically, over the past few years, I've gotten increasingly interested in understanding human AI interaction. And so the puzzle here is that the Allegheny family screening tool is in many ways like more disparate or disproportionate than the status quo, than human-only decision-making. So if you, this is kind of what this plot that I skipped over shows. This is the screened rate disparity, like the blue curve is the screened rate disparity, if you just automate it according to the AFST, right? And really we're somewhere like out here. So you'd expect a bigger disparity if you fully automated ththings according to the AFST than you saw under human-only decision-making pre-deployment. So what actually happens is, like what anyone would probably predict, you take a tool that in its classifications has greater racial disparities than humans did in their decision-making. You give it to humans and it reduces disparities. Okay. And so I think these evaluation studies are super important because we have a very limited understanding of what happens when you give a person a risk model and like how the formal properties of that risk model actually translate into downstream outcomes. So I think this is super interesting. It's a piece of the puzzle that's critical that we don't understand very well. So I think these evaluation studies where we can get really good data and ask precise questions and actually see what happened are going to be the gold standard for quite some time. Because if you tell me the formal properties of a model, I can't reliably actually predict what is going to happen in the end. Yeah.
There's some questions on Zoom.
Okay.
So I can read them out. The first one is from Thomas Richardson. Please can you say more about finding two that decisions are not aligning with the score when the score is known?
This one. Okay.
Yes.
Okay, great. Yeah, so this is totally bizarre. So let me tell you what's going on here. This is showing like the score now translated into probability of placement risk as opposed to a 1 to 20 scale sort of thing on the x-axis and the screen-in rate on the y-axis. The screen-in rate when people are randomized to have access to the tool is shown in green, and the screen-in rate when they don't have the tool is shown in blue, right? So there is a stronger positive relationship between the model's assessed risk and screening decisions in the blue curve, which is when they don't have a tool, than in the green curve, which actually peaks somewhere in the middle or is flat. I mean, the uncertainty is very high in this case. Okay, they ran into some issues with actually deploying the RCT, but filtered down the data appropriately. So the authors offer an explanation for this, which is that they went back and they talked to the workers, and the workers said, oh, well, once we saw the risk scores, we found them really useful because they allowed us to focus on other more relevant aspects of the case. And perhaps that's borne out by this reduction in child injury hospitalizations, that somehow they were able to tune into something that was more related to like physical abuse. But at the same time, that kind of like explains too much. Like if it allowed you to tune in to elements of the case that were most salient, and this tool is actually doing a good job of assessing risk, like wouldn't you actually expect decisions to be more aligned rather than less aligned? So I don't think they have a very satisfying explanation, and I'm not sure I would necessarily be inclined to believe an explanation because this is the first time I've seen this phenomenon. So I think like more work is required. Thomas, does this answer your question or at least like clarify the result?
Yes, it does. Thank you. So just to tie this to the previous comment that you made, where you were saying that after the system was deployed, disparities went down. So I'm just trying to understand, is that because people are aware that they're being benchmarked against an algorithm, or is it or do you think that's because the algorithm sees sort of that there are human blind spots that maybe the algorithm doesn't have, that in some sense they're complementing one another? I don't know. I guess you said it was complicated, but I'm curious to know.
Yeah. So the analysis the authors present, I don't think shines definitive light into that question. But there is some ongoing work by some economists at UT Austin that are actually trying to tease apart, like for what sorts of cases are humans better at making decisions? For what sorts of cases does it look like these child welfare risk scores are better? But this current study doesn't speak to that, and one can come up with various hypotheses that are consistent with the data. But it's hard to know, or it's impossible to know, I think, from the analysis that they presented, which of them is substantiated and which are just hypotheses.
But just in the previous slide where you had the before and after, the slide the one with the green line and the blue line, that one, yes, exactly. So post deployment, so that the decision makers know what the AFST score is. Is that correct?
Yeah, for
Yeah.
all of them. Yeah, so these are different settings,
Okay.
like one's an RCT, one's
Okay.
observational, et cetera. Yeah.
Got it. Great. Thanks.
All right, yes, so there's more questions, but we'll pass them on to you after this.
Okay.
Sorry, we're over time, so we'll wrap up.